Greetings everyone, I am Rahul Mishra. Today we will dive more into digital forensics and will talk about extraction of information from the media. Extraction of information from media is one of the most crucial parts of cybercrime investigation. This step is a part of non-live forensics. Remember, forensics has two parts: live forensics, which is done on a system which is switched on; non-live forensics, which is done on storage devices. Here we only cover the non-live forensics part. Now, in case of extraction of information, the information we need to extract depends on what type of crime has been committed or what type of service is requested by the client, according to the details filled in the request for service form. Now, the type of information may include file system information such as directory structure, file attributes, file names, date and time stamps, file size and location. Some deleted files may also contain important information which needs to be recovered. Files containing user ID and passwords of some accounts can be of good use. Extraction data from password protected or encrypted files can be of great help from the investigation. Information stored in file slack is also of great help. Now, the question is, what is file slack? In order to understand that, we need to understand first how data is stored in memory. Data is not stored bit by bit in sequential order. Some amount of memory is grouped in sectors. Each sector is of 512 bytes. Then sectors are grouped into clusters. Clusters are of variable size depending on the file system in use. Files are stored in clusters. For example, there is a file of 11 KB and the cluster is of 4 KB each. So, the file will acquire 3 clusters acquiring 12 KB. Now, 11 KB is the logical size of the file, while 12 KB is called physical size. Whenever we look into the properties of a file in Windows, it shows two types of file sizes which are logical and physical. There is very little possibility that these sizes will match. Now, coming to our example, we can see that there is a gap of 1 KB which is unused by the file. This gap cannot be allocated to any other file and is called file slack. Now, consider that the user deletes the file. So, when user deletes a file, only his entry from a table is deleted. The operating system maintains a table of where the file is located in memory. So, the entry is deleted, but the actual file is present in the memory. Now, consider that the operating system needs to store another file of 10 KB onto the previous location. So, it overwrites the previous file with the new file, but the new file is of 10 KB and the old one is of 11 KB. So, the old file is not completely overwritten. 1 KB of the old file can be recovered, which may prove to be important for investigation. That is why file slacks are retrieved. RFS, also known as request for service, is the form filled by the client who wants service from us. In this form, he or she explains all the details about the incident, details of the media and the type of service needed. It is on the basis of RFS that the information extraction process begins. COC form is filled. COC stands for chain of custody. This is filled by the investigator, where he or she fills in every detail about the media, procedures followed to recover information, etc. Next is cloning and imaging. These are one of the important keywords used in investigation. Although they are not completely similar, they are similar in the sense that they both do a bit by bit copy of evidence, including the boot information, and the deleted files are copied. But the difference is that in case of cloning, cloned file can only be accessed if the cloned media is attached to the system while imaged file is portable. Now, the two most common tools for information retrieval are WinX and autopsy. WinX is a tool used to calculate hash of the evidence and the image, and also used to create the image of the evidence. Autopsy is used to recover files from the image and generate detailed report about the image. While WinX can also recover files, we prefer autopsy because it is easy to use tool and an automated report can be generated for documentation purposes. Now, the procedure of the evidence extraction begins from first, filing of RFS and COC form. Second, calculate hash of the evidence. Third, create image of the evidence. Fourth, calculate hash of the image. Fifth, match the two hashes to confirm that at time of imaging the evidence has not been tampered with. Sixth, finally, the information is retrieved from the image. Seventh, proper documentation should be maintained for each step. Eighth, update the COC form if needed. Now, there are certain things to remember while evidence analysis is done. First and foremost, use of licensed software is preferred. Unlicensed software may bring the investigator into a lot of trouble while presenting information to the court. No type of information retrieval is done on original media, as it may affect the media itself. While imaging the evidence, it should be write protected so that no one can write into the evidence. This can be achieved by using a write blocker. Write blocker can be a hardware or a software program which prevents anyone to write into the evidence. While selecting on what to image, we should select the evidence which is located under physical drive and not under the logical drive. In case of imaging a hard disk which has lot of partitions, the physical drive should be selected instead of imaging each partition separately. This is because certain locations are reserved for operating system for its own use, which can be imaged if logical partition is selected. Now, we will do a demo of WinX. Let us now see how an investigator extracts data from a storage media like pen drive or hard drive. For our demo, we are using a SanDisk 16 GB pen drive. We are going to use software called WinX, which belongs to X-Ways Forensics. We open the software with administrator privileges. Remember, the software won't be able to detect the existence of physical drives if you do not provide administrator privileges. Once it opens up, we need to select the physical drive. In our case, it is a pen drive. In order to do that, we click on Tools, then click on Open Disk. It will then show us a list of logical drives and a list of physical drives. We now need to select the pen drive from the list of physical drives. It is important to have a practice to choose the hardware from the list of physical drives, since selecting physical drives show the complete memory size unlike the logical drives. After that, we click on OK. It will open the pen drive inside the WinX software. Now, as an investigator, we need to generate a hash. A hash is a unique 64 or 128 character string alphanumeric which can be used to prove the integrity of the evidence. As an investigator, it is very important to prove that the digital evidence has not been tampered by anyone while it was being investigated. The best way to do so is to check the integrity of the evidence by generating a hash. So, we go to Tools again and click on Compute Hash. Then from the drop down list, we choose SHA 256, which is accepted by law. Then we click on OK. It will start generating the hash. The time taken to generate the hash depends on the speed of the machine as well as the size of the hardware that is being hashed. It is important to understand that the investigators do not perform any type of investigative operation on original evidences. There can be multiple issues while investigating on a real evidence. For example, the evidence might get corrupt or some files get deleted. In that case, the evidence will be impure and cannot be submitted to court. So, we create an exact copy of the evidence and analyze the same. In technical terms, it is called cloning or imaging. Both these terms are similar. The only difference is, in order to clone a drive, you need to connect another empty drive of the same size as the original evidence. For example, if we want to clone our demo pen drive, which is of 16 GB, we need to connect another empty pen drive of 16 GB to do so. In case of imaging, we generate a file of the size of the evidence. So, if we create an image of our demo pen drive, we will generate a file of 16 GB, which can be easily transferred to another location for further analysis. Once the software generates the hash, we need to copy the hash to a secure location. For a demo, we just copy it to a notepad file. We are not done with the hashing of the original evidence. The next step is to generate an image of the evidence. We are not going to clone the evidence since we do not have an empty pen drive of the same size as the evidence. In WinX, the imaging or cloning is done from the same menu. In order to image, we again click on Tools, then go to Disk Tools and click on Clone Disk. Here, we need to choose the original evidence first. So, we click on the drive icon under the source medium and choose our pen drive from the physical devices list and click on OK. Now, we need to select a file where we want to store the image. So, we click on the file icon under the destination raw image file. We then need to name the file. Choose a location to store it and click on OK. The name can be anything. Make sure that copy the entire medium at the top right is checked. After that, we need to click on OK. The imaging process will start. It will take a few minutes depending on the speed of the machine and the size of the drive we are imaging. Once the imaging process is done, it will show you the log. For our demo, we do not need the log, so we close it. Now comes the next step, which is to verify that the original evidence and the image of the evidence are exactly same. So, in order to do that, we generate a hash of the evidence and then generate a hash of the image. If both the hashes match, then we can prove that the image is the exact copy of the evidence. If it is proven, then only any analysis on the image can be submitted to court. It is the feature of a hash that for two completely equal inputs, the hashes are same. We have already generated a hash of the original evidence previously and stored it in a notepad file. Now, we just need to generate a hash of the image file. The image file is already opened in the software, so we go to Tools, click on Compute Hash. We again choose SHA-256 and click on OK. Once the hash is generated, we store it to a secure location. For our demo, we store it in the same file as the original evidence. From the both outputs, we can verify that the original evidence and the image file are same. I will conclude here. This is how we generate an image of the evidence. After that image generation is complete, we can move on to the extraction part. We should always remember the ultimate goal in digital forensics, which is to preserve the evidence in its purest form. There can be a lot of complications while doing so. This was the most crucial part. Any problem with the above steps will only mean that the evidence collected from further analysis will be unacceptable to the court.